Welcome to this series of web lectures on mathematical modeling for transport and mobility. I am Leila Martin and I'm going to walk you through a quick introduction into this series of web lectures. So what are we actually going to look into? So we're going to look into broadly transport and mobility. So for that, we first have to understand the basics of mathematical modeling and operations research, because otherwise we cannot actually model the problems that are specific for transport and mobility. Specifically for transport and mobility, we're going to look into two different rough streams. The first one being network flow and network design. So one of the questions that we might ask within that is, where do we place a facility? A facility in the transport context could, for example, be a cross-docking site. The second stream of mathematical models that we're going to look into is vehicle routing. So within vehicle routing, we're asking, for example, the question, in which order a parcel delivery company should deliver parcels to individual households. And in addition, I am going to provide you with some insights on the transport industry, because obviously what we're trying to model is we're going to try to model how transport companies are making decisions, and for that we need to understand how the transport industry functions. So if we're looking into the learning objectives, we have 4 different learning objectives which partially build upon each other. So we're going to learn how to read and explain mathematical models. So for example, you're given a mathematical model and you have to explain what this actually optimizes. Then we're going to look into writing mathematical models, which on the one hand side can mean actually just writing the entire mathematical model, but on the other hand can also mean extending and adapting mathematical models. So you would be given a basic mathematical model and you would be asked to say, for example, add a constraint that limits the point in time during the day that a certain customer can receive his parcel. And lastly, we're going to look into correcting math models. So for example, the task would be something like, you see that this mathematical model gives you this very weird solution. Explain to me why this is a weird solution, how you can correct this mathematical model that no longer gives you this weird solution. Just to give you a little bit of insight about who I am and why I am teaching this course. So I am Leila Martin, as I already said, and I'm an assistant professor for transport and logistics at the Eindhoven University of Technology. And within TUE, I am part of the Operations Planning, Accounting and Control Group, which is part of the School for Industrial Engineering. And I am teaching a variety of courses here at TUE, including transport and distribution on the bachelor level and decision-making for transport and mobility on the master's level. And in my own research, I'm looking into optimization and decision-making within the transport and mobility sector. And my focus within that lies on understanding the effects of competition. It lies on integrating customer centricity, making these models a little bit more good for the customer or modeling the customer in a little bit more detail. And lastly, also on sustainability. And this course, so these materials are also being used throughout various courses at TUE. So the biggest one being transport and distribution, part of our bachelor program of industrial engineering, and throughout various courses in our master program as a support or as a foundation. And our master program in this case is operations management and logistics. Thanks.